Hello friends, in this session today, let's understand about the concept of Azure Synapse, tables creation, partitions, indexes and degree of parallelism DOP options. Come on, let's get started. Let's understand what exactly Synapse tables are and what are the different variants, different types. Well, Azure Synapse is a database, basically a database. It's a data warehouse to store a huge amount of historical data, unlimited data. And it also supports poly-based technology, which is mainly used for faster data loads, auto-indexed in-memory data load activities. Yes, here we go. In the Azure Business Intelligence Implementation platform or the workflow environment given by Microsoft, the Azure BI implementation, Synapse is one of the key repository, one of the key platform, a common destination for wide variety of data loads. And Polybase is an extra feather in Synapse cap, which is making it more powerful for faster data loads and faster operations, especially in ETL environment. Now let's understand in an Azure SQL server, inside an Azure SQL server, you log into your Azure portal, you get into your Azure SQL server, you create your Azure SQL server, and this is the concept we are understanding right now. Operating on new Synapse SQL pool. Yes, provide some name. I'll say Azure SQL Synapse pool. Give some name, a meaningful name. It's basically a data warehouse. Click on performance level. We need to specify our resources level, the level of investment of resources. I'll say for now 100 DWCs. Yes, we are not concentrating on the architecture of Synapse here. We are only concentrating in this particular class. We are concentrating on the tables, right? And the tuning options. So let's create the Synapse warehouse database. It would take a couple of minutes to get created. In the meantime, let's understand about how to operate on it slowly, step by step. Yes, either by using SSMS tool or ADS, Azure Data Studio tool, you would connect your Synapse database. Your SQL server, logical SQL server has actually 3 different types of databases that can be supported. Regular SQL databases, Synapse database, or actual agenda item today, and something else called stretch database that can store cold data from on-premise. We can offshore cold data from on-premise, a separate topic for us altogether. We are concentrating on SQL pool. So similar to other databases, Azure SQL Synapse also store the data in the form of tables. But these tables look a bit different. Let's get started now. How Azure Synapse tables are different from that of your regular SQL tables. Number 1, auto-indexed. Yes, every table is automatically indexed for faster access. Azure Synapse table does not support foreign keys. So all data validations would be completed in the ETL environment and if required from your regular SQL and other database sources as well. Synapse does not support foreign keys. and every Azure Synapse table is to be partitioned. So every table should be stored as per one of the below distributions: round robin, hash, and replicate. Three different options. Let's understand round robin, what actually it means. We are going to practice all these three today. Round robin, it's the simplest one and fast for smaller workloads. It distributes the data evenly. There's a concept. Without any further optimization, simply distribute the data. So a distribution is first chosen at random. For example, distribution number 4, then 5, 6, 7, again 1, 2, 7, again 1, 2, 7, again 1, 2, 3, 4, 5, 6, 7, something like that. It will choose one particular distribution at random. Number 4, 5, 6, 7. Assuming there are 7 distributions, 7 different partitions. Again 1, 2, 3, 4, 5, 6, 7. Again 1, 2, 3, 4, 5, 6, 7. So on the story continues. And moderate performance for joins. Not too less, not too more. So here is the example. Assume a table with 100 rows. Then in such a case, here it is. Assume a table with 100 rows. In such a case, the control node in your Synapse data warehouse architecture, a separate chapter for data warehouse architecture, there is something called control node. This control node will decide. The control node in Synapse architecture will decide the distributions. So assume 3 distributions. Then row 1 we may go to first partition, row 2 second, row 3 third. Again row 1 first, row 4 first, row 5 second, so on it continues. Hash distribution. It delivers highest query performance for joins and aggregations on big tables. It uses hash function. So we have to specify a hash key today. In next 5 minutes we'll start our practice. There we see a hash key to be assigned to each row to a distribution. So hash values or hash functions use one specific column that you have to provide, and again the entire control takes place from the control node itself. So we control the column value. Then what control node will control? Yes, it will control the parallel operations to as distributed tables. For example, in one of our classes, we have one example to load some 17 crore data into Synapse. So we can't expect the row-wise data to be written in sequential, right? It goes in parallel. That parallel computations, parallel data warehousing activities would be controlled by control node as per the Synapse architecture. Something like this. Table is now hashed to multiple compute nodes and distributed tables. So table is distributed across multiple storage environments. Replicated table. For very small tables, we generally use it. Data is simply replicated to multiple environments. Observe carefully here. So we require extra storage for this data duplication. Let's understand now how to perform these replication activities, or how to perform these tables, Synapse tables creation. So in the meantime, I believe my deployment is successful. Let's go to our database. We know how to establish connection to our server, Azure SQL Server from SSMS. We are only concentrating on the Synapse tables here. And let's take it in this way. Your class notes includes one specific practice file that you will be using now. Let's see, friends. A simple and straightforward process. Well, here we go. How to create a basic table in Synapse. Remember, it is auto-indexed. Okay, it's auto-indexed. We'll verify it. Or create second table, Synapse table 2 with a constraint, just to get some idea. We know SQL Server, we know T-SQL. Right? Now try to correlate the things carefully here. We are new to Synapse. Now, how to create table with ColumnStore index? ColumnStore index means an index that stores unique values of a column. An index that stores unique values of a column. We call it as ColumnStore index. And insert values into the table. You can insert the values. General SQL Server T-SQL, this works. But in Synapse, it won't work. We can't have default values directly like this. Whereas regular operations will work. Regular operations will work and we are able to see the data. Let me maximize it. Remember, to audit indexes, yes, we have been creating few tables. I said every table is auto-indexed. How do you know sys.indexes? There are 3 tables, so 3 indexes. We can also report in this way. Remember, SP help index will not work. It will not work in Synapse. Regular SQL Server, we know SP help index will work. Here it won't work. So as per our course curriculum, we know that SQL Server Transact SQL basics are required, okay, to step into our Synapse, ADF and data engineering course. Basics should be fine. Just do revise them and do let me know for questions if any. Well, from Object Explorer, we can verify the columns, constraints, and other activities. From the Object Explorer, we can verify them. So here we go. Right click Synapse, refresh. Expand tables. And here it is. You get the values in this way. Now, how to create round robin tables? Create table name with distribution equal to round robin as select. See here. DOP, degree of parallelism. Observe carefully. We are creating this table. We are only focusing on the table creation and optimization techniques. Synapse architecture, a separate chapter, separate class. Table data loads, separate chapter, separate class. We need to create logins, users, and other things. There's something called RC, resource classes, to perform big data loads. Let's concentrate on the tuning techniques which are very much vital to get into big data loads. Creating a table. Table 4. Here, distribution equal to round robin. Remember, we have 3 different types of distributions. Round robin, hash, and replicate. We are now taking the round robin. Now, output of this table 3, Small sample output is used as input for table 4. DOP3, what does it mean? Yes, here it is. The number of degree of parallelism, number of operations that can be done at a time. Simply say number of operations. Here operation means inserts, upsets, anything. Number of operations that can be performed at a time. That is called DOP, to make it simple and straight. Next, a small variation. We can also have a clustered index with distribution equal to hash. ID, what is ID? It's a key, hash key. Here range, partition range is computed automatically. We can also control our own range. We'll do it in the next level activity now. Before we proceed, just like our regular SQL server, here also we can create a temporary hash table. Yes, Azure SQL server also has tempdb. It is hidden, but it is there. Every database will be associated with its own tempdb copy. We can create local temporary tables, global temporary tables. We can also make use of sort in tempdb on option. If you are from SQL Server developer or admin background, sort in tempdb will work. Just give it a try. How to create replicated table? Distribution equal to replicate. This way. Next, I repeat once again my last statement. If you are from SQL Server dev or admin background, okay, try this. Try this sort in tempdb option. Try the sort in tempdb option that we generally use for the index creations. Give a try. It works. Clearly means there is tempdb in Synapse. There are other commands as well in our journey to understand the use of tempdb for a dedicated Synapse database. Next, how to create new table from existing tables? Actually, a repeated one. It's already there in the previous example. Here it is. For example, here you go with round robin, clustered index, or here round robin clustered index with ID. See there? We are using one particular column from Synapse table 7, ID column, for defining the index. Same way, very important, mainly for big data activities, we have partitions. Here we go. Create table, table name, partition, and see there friends, create table with partition left means all values up to 10, one range, 11 to 20, another range, so on. See there now, I'll wait. Same way. Here we go. Observe carefully. Create table, table name. Here, same table, partition range right. What is right here? Right means up to 9 becomes one partition. Above 9 up to 19, second partition. Above 19 means from 20 to 29, third partition. So on. So here it is, P1 is up to 9. P2 is 10 to 19. P3 is 20 to 29, etc. So this is how range left, range right works. And additionally, I don't want to compare every time with Transact SQL or regular SQL server, but in fact, it's the same concept. No difference here. Distributions are different, okay, remaining all same. And now, apart from this, we have previous examples, distributions, current examples, partitions. Now, very important here, distribution and partition together. What's the difference between a distribution and a partition? Distribution means how you would like to distribute the data, how you would like to span the data across multiple entries. Whereas partition, in simple terms, partition is logical table concept. Logically, we say these many rows, one partition, these many rows, another partition, like this. Say, for example, 1 to 10, one partition, 11 to 20, another partition. Logical division of data. Distribution is something related to storage. At the physical storage level, for example, you replicate it, right? We say distribution equal to replicate. Say distribution equal to, say, replicate. What does it mean? You would like to have some redundant copy, like duplicate copy, a mirrored copy. That is what distribution means. Distribution pertain to storage. Partition pertain to logical division of your data. Now, how to create table with date partitions? Here it is. Just a small example to make our things easier to understand. Sometimes when working with big data, these examples are very much required for us. Coming back to our notes again. Yes, here it is. Partition and distribution. How they are different from each other. Just in case on my screen. So we got partition and distribution. Partition is a regular database activity. Every database supports partition. Whereas distribution is supported only by massively parallel processing databases like Synapse and Azure Data Lake Storage, USQL catalog databases. It's a hardware concept. Storage level, hash, replication, etc. For example, partition is a small diagram I have taken from Microsoft Azure site, and here you go, microsoft.azure.com. There you see a table with A, B, C, so on, some key values, A to B, one shard, A to G shard. From there you get one partition. This is called a shard. Whereas remaining H to Z, another shard, another set altogether. We are dividing the table data into multiple places. But how you actually store at the disk level, right? There comes distribution. For example, replicated data this way. Okay, so you'll practice these items carefully. If in case you are from SQL Server background, you got few more examples on how to perform partition management and archival process also in the same script. You'll practice all these items carefully and use me for your doubts and clarifications. Kindly make sure we practice on time throughout the course. Thank you very much. Have a nice time. My kind request, practice on time. Thank you once again. Have a nice day.